Hello and welcome back. Today we'll be doing question 2 from the 2007 Step Paper 3. This question is about the sum of factorials. Let's get started. Question 2, part 1. Show that 1 times 3 times 5 times 7 all the way to 2n minus 1 is equal to the factorial of 2n over 2 to the n multiplied by n factorial, and that for the modulus of x is less than 1/4, 1 over the square root of 1 take away 4x is equal to 1 plus the sum from n equals 1 to n equals infinity of the factorial of 2n over the factorial of n squared multiplied by x to the n. Part 2. By differentiating the above result, deduce that the sum from n equals 1 to n equals infinity of the factorial of 2n over the factorial of n multiplied by the factorial of n minus 1 multiplied by 6 over 25 all to the n is equal to 60. Part 3. Show that the sum from n equals 1 to n equals infinity of 2 to the n plus 1 multiplied by the factorial of 2n over 3 to the 2n multiplied by the factorial of n plus 1 multiplied by n factorial is equal to 1. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll write 1 times 3 times 5 times 7 all the way to 2n minus 1 as 1 times 2 times 3 times 4 all the way to 2n over 2 times 4 times 6 times 8 all the way to 2n. We can simplify the denominator to be 2 to the n of 1 times 2 times 3 times 4 all the way to n, and therefore we have that 1 times 3 times 5 times 7 all the way to 2n minus 1 is equal to the factorial of 2n over n factorial multiplied by 2 to the n as required. We may now use the binomial theorem to expand 1 take 4x to the negative 1/2, and this is valid for all modulus x is less than 1/4. This expands to 1 plus negative 1/2 of negative 4x plus negative 1/2 multiplied by negative 3/2 multiplied by negative 4x all squared all over 2 factorial and etc. This is equal to 1 plus the sum from n equals 1 to n equals infinity of 1 multiplied by 3 multiplied by 5 all the way to 2n minus 1 all over n factorial, all multiplied by 2x to the n. This simplifies down to 1 plus the sum from n equals 1 to n equals infinity of the factorial of 2n over n factorial, all multiplied by x to the n as required. Now we can move on to part 2. Here we can differentiate both sides and multiply through by x to give 2x over 1 take 4x all to the 3 over 2 is equal to the sum from n equals 1 to n equals infinity of the factorial of 2n multiplied by x to the n all over n factorial multiplied by the factorial of n take 1. From here, substituting x equals 6 over 25 will give the required result as required. Finally, we can move on to part 3. Here, we'll do something similar and we will integrate both sides to get the negative square root of 1 take 4x all over 2 is equal to x plus the sum from n equals 1 to n equals infinity of the factorial of 2n multiplied by x to the n plus 1 all over n factorial multiplied by the factorial of n plus 1 plus the integrating constant. Substituting x equals 0 will give us c is equal to negative 1/2, And from there, substituting x equals 2 over 9 gives negative 1/6 is equal to 2 over 9, take 1 over 2, plus the sum from n equals 1 to n equals infinity of the factorial of 2 to the n multiplied by 2 to the n plus 1, all over n factorial, factorial of n plus 1, 3 to the 2n plus 2. And multiplying by 9 throughout gives the required result. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.